Okay. True. Beginning. Oh, I'm Bas from Possum Labs. This is a recording of the presentation on how and why to use a domain-specific language for testing. So first of all, let's talk about domain-specific languages. There's a good chance that you've used them in the past. You may be familiar with regular expressions. This is a particular nice one that will validate JSON for you. It won't work in .NET, but it will work in a number of other languages. Not the most readable thing. Expats is another one. This one actually finds a cell inside of a table for HTML. This one actually doesn't work properly if you have multiple tables, but it's a handy little expat. And again, this thing is pretty much unreadable when people are unfamiliar with expats. But here's another example of a domain-specific language, and this is what Alexa uses. Right? These are the commands that Alexa has that deal with timers. Now, anyone who has an Alexa or any kind of home automation thing that you can talk to understands that when you talk to your friends to explain what it does, it will be listening and it will start telling you about random dino facts. That's because it doesn't actually understand English. What it actually understands is very specific commands. And here are some of these specific commands, right? We can set up timers, we can check how much time is left, we can ask what timers there are, you can give timers names, you can have variable names in this case, and you can reference to them by those names. So what we're going to be talking about is this kind of domain-specific language. Something that piggybacks on our understanding of English and uses that to create a very easy to understand user interface, not a graphical user interface, but in this case a language user interface to convey information to our users. So for our examples, we'll be talking about 5280 Apex Human Resource Solutions. This is a fictional company. If you're in the Denver area, you'll probably know that lots of companies are called 5280 or Apex. For people outside of it, that's why it's called that. Now, some of these examples may sound familiar, and that's probably because these events happen quite often. So in the beginning, the tests are green, deployments happen, and nobody really wonders about what's going on. So this is, a number of years ago at our fictional company. It was like magic, right? Stuff just happened. And then something went wrong. What actually went wrong doesn't really matter. What's important is that it was bad. And because it was so bad, people decided that things had to change. But then we had the next release and the tests were green. And it was like magic. But what happened was people no longer trusted the magic, right? It was green last time, they got burned, it's green this time. What does green mean? Because really what happens when you say the tests are green is you say, it's all good, trust me. Right? And what's going to happen with the business is well, show me. Make us understand what you're actually testing. And then you end up with something like this. These particular unit tests are pulled out of some Microsoft code. They are for a wrapper provider factory test. And quite frankly, I don't think that your code is complete unless it includes a wrapper provider factory at some point or another. But rarely does your business actually care about something archaic like that. Yes, you probably need it to make all the code work and to allow you to not have a lot of duplication. But chances are your business doesn't care about this. So these test cases, even though, they're semi-readable if you know code, to the business are completely meaningless because they're testing something that by its very nature is completely meaningless. And that's just the nature of unit tests. So what we're trying to accomplish here is that we're going to build up trust, right? And if you lose internal trust, what's going to happen is people are going to do manual regressions. There's going to be slow sign-off processes, slow releases. All of these things are going to start creeping in because the business wants to make sure that when they say it's okay to release code, nobody's going to get in trouble. If you're unlucky and your customers lose trust, then they're going to stop taking updates. This can be very challenging. Because now you can have multiple of your customers on different versions, and if you're in a regulated industry, that means that you may still have to ship updates, like patches, for multiple versions of your product. This becomes very expensive to maintain, especially for smaller companies. So what we want to do with our test cases to rebuild this trust is we want to start out with English. And there's a couple of reasons for it. One, your business will never read your C#, Java, JavaScript, or Lisp. It's not going to happen. They can, however, read English, right? And the business needs to be able to read these tests. So we have to write a test in English, which, funny enough, is exactly what manual regression scripts are. Right? That everyone can read them, you know exactly what's being tested, there's no confusion about it whatsoever. So let's start looking at English. What are the benefits and drawbacks of using English? So first up, English is amazing at telling stories. It's what I do right now. So here's a small story. You may have seen this before. A businessman had just turned off the lights in the store when a man appeared and demanded money. The owner opened a cash register. The contents of the cash register were scooped up and the man sped away. A member of the police force was notified promptly. So let's see if we all understood the story the same. Right? So a man appeared after the owner had turned off the lights. Is this true, unknown, false? Just keep track for yourself. The robber was a man. The man did not demand money. The man who opened the cash register was the owner. The store owner scooped up the contents of the cash register and ran away. So the last one probably was a little confusing. It was a different interpretation, and then you're like, well, what did the story really say, right? What wouldn't surprise you is that most people who answer these questions end up with different information. And a lot of that comes down to the context. Right? Natural language is, by itself, especially when in short form, pretty terrible for conveying clarity. Right? If you send text messages to people, you know they will be misunderstood. But what we're trying to do with this communication is we're trying to get to the point where everyone has the same understanding. So even though you may have looked at those previous questions and wondered like, hey, well, this is right and this is wrong, there's a correct way to interpret this, it doesn't really help unless everyone has the same interpretation. Alright, so this story originally came out in 1955, an uncritical inference test. If you've had this information, chances are you would have read the story different already, right? You would have had more context. So let's change the story a little bit, and we're going to introduce variables, similar to what we saw in the Alexa timers, right? We're just going to give things names. So here's an example, and this made it a robbery story, right? Person A had just turned off the lights in the store when person B appeared and demanded money. Person A opened the cash register, the contents of the cash register were scooped up, and person B sped away. A member of the police force was notified promptly by person A. If you're working at a company that makes software for police departments, you probably had assumed already that this was going to be a robbery story. However, if you were working at a company that was working on consumer rights, probably assumed that the person who demanded money just wanted a refund and probably was in the right. Right? To them, this is a story where person A turned off the light, person B wanted his refund, person A took the money and ran away, and the person who ended up calling the police probably was the customer. So it really depends on perspective. For instance, here's another example. If you were working on software that supported female business owners, then if a businessman was turning off the lights and a man appeared and the owner opened the cash register, well, the owner is always a woman. So you would have noticed immediately that there's 3 people in the story. And again, that all comes down to with what perspective you would read this particular story. The only way you can really be certain about what's going on in these stories is when you have a perspective like this. If you work for M. Night Shyamalan, then you would have known it's person A all along. Right? There never was anyone else. So one of the things that we have accomplished with this is that, we can take these stories that English is very good at, and we can add variable names to this. Right? This is the same thing we do when we tell stories to other people. We give people names or nicknames. Right? Because that way people can keep track as to who is doing what at what point in the story. If you were to read a novel and nobody had a name, it'd be very difficult to figure out what's going on when and where. So we can combine some of these concepts from computer science, the variables, and the English right? And still create something that's readable, even though it's turning into something that you normally wouldn't read as natural language, right? The English you would have in your everyday life. All right, so let's actually go to some test cases. So our HR management application is very simple. It keeps track of the CEO after somebody retires. So we're going to get started and we're going to say, okay, we've got a small organization and we have P1 retire and then P2 should be the CEO. Now we still have some missing context here, right? Because we don't exactly know what the relationship is between P1 and P2. So our entire organization, everyone we work with, would need to understand what this small organization is. Right? And we can say like, well, it's a small organization that has P1 and P2. You've got some more context and you can use that information. But it doesn't scale, right? Once you have an organization that has like 8 people in it, it's really hard to say like, well, do they all report on like one long chain or is it like a pyramid, right? How is it organized? Do we count from left to right or do we count horizontally across the org chart? What's going on? So in that case, you would do something like golden data, right? You'd say like, hey, we're going to have these well-defined organizations. And this way everyone knows what these look like and you can look up exactly who P3 and who P8 is in these organizations. Again, the looking up is going to become difficult, right? This is the problem with golden data. You assume that everyone has this well-known existing data. It's really easy to get started and it's really difficult to scale and exceptionally hard to maintain. And the reason for this is that when you create the data the first time, you're handling particular test cases. But what ends up happening is that to handle specific test cases, you're going to need to keep more and more and more of these data sets. And as your application advances, these data sets all need to be maintained. They all need to have these additional fields populated. And every time you have new fields being added, you're wondering like, well, should I keep this data set with the same? Should I choose option A? Should I choose option B? Should I make 2 data sets, one for option A and one for option B? That's a problem with maintenance. The golden data is useful. Like you're still going to end up using it in some places, like especially when you need like an application and you need to log in. Right? Having an admin account just set up is really convenient. It's like the most basic version of a golden data set. You have an existing account. But when it comes to actual large hierarchical data, it becomes really difficult to maintain that. All right, so let's take a look at English. All right, so here is some amazing English. Take a moment to read it. This originally came from Tolkien in Lord of the Rings. Okay, so chances are this includes a lot of words that you do not use in your everyday life. It includes a lot of words I don't use in my everyday life. But if you were to draw a picture of this tree, and I were to draw a picture of this tree, they would look fairly similar, right? It conveys a lot of context. It conveys a lot of information about what this thing looks like, even though it's not very specific because you don't really have a good understanding of what's going on. And that's partially because of the number of words, right? This has a lot of words we don't use in our everyday life. And then when you look at it, the number of words people use varies greatly. Like for a 20-year-old, you can see between 27,000 to 52,000 words. These words are great to convey information. But if you have words that other people don't use, it becomes ambiguous, right? The definition isn't clear. So what we're going to be aiming for isn't really something like a 20-year-old. It's more like somebody like a 4-year-old. Imagine a 4-year-old that grew up underneath your conference room table. They just speak the words to describe your application. It sounds a little rudimentary, but it does remove a lot of the ambiguity. Right? So we can, of course, try and say like, well, we're just going to solve for the golden data set, right? This particular tree is called Old Man Willow. So person A sees Old Man Willow. Great, but everyone would have to be an expert of all the different things that exist in the world. This doesn't really work. You need to have a way to describe this data. This gets back to our problem with the golden data set. So what we could do is we can use something that is still English, right? You can look at it, it's a table, like you wouldn't write it an email like this, but you can still convey some information. And you can just start adding attributes. And you can even build a hierarchy, right? You can say like, I've got a branch, I've got like another branch, and I'm going to give them some information, and then I'm going to associate these branches to a tree. You can build up a hierarchy. And we can do the same thing when it comes to our employees. We can say, given the employees, E1 and E2, we call them Bob 1 and Bob 2, and they both report to Mary, right? We have var E3 named Mary, and that one has two reports, E1 and E2. So our goal for our domain-specific language is that it's clear, right? It has a limited vocabulary, so it's clear to understand exactly what everything means. And we want to name all the things we want to reference in the future, so it's easy to keep track of things and allows us to combine these little rudimentary elements of our language and build more complex structures. Right? We want to be human readable, right? To be able to get the business to trust what we're testing, right? To show them exactly what works in the application, it has to be human readable. But on the flip side, we also want to be machine parsable. Because if we make this machine parsable, that allows us to get to the point where we can use this to actually write test cases. And this is where you create your domain-specific language. Right? If you're familiar with domain-driven design, the variables, the things that you give names, are probably going to correspond to the entities in your domain model. Right? The adjectives becomes your properties, the verbs are your actions, and when you combine all this information, you're effectively creating the ubiquitous language if you're familiar with the domain-driven design methodology. It's trying to build that in the most rudimentary form so that we can use it to define how the application is going to work in a way that we can easily teach to a computer. So here this is in action. Here's our human resource solution again, and here we have some test cases, right? Again, our system is really simple. It just keeps track of a hierarchy of employees. You specify who is the CEO, which is denoted here, and the root employee is. And then we retire people, we keep track of things. And we can use just some more concepts from coding, right? The dot notation that we have in here to keep track of some information. And we can use that to say, okay, well, this is what the world looks like. This is the objects. This is how they relate to each other. We're going to have an action happen, and now we're going to refer to it further down the line to verify things. The first scenario is very simple, right? We have a promotion scenario. We just have two people. The second scenario is more complicated. We have multiple employees with different seniority. We can track how these things interact with each other, and we end up building up a new hierarchy after somebody gets promoted to be the CEO. So this English is readable, right? You think it is English when you interact with it. But you're also starting to realize, like, no, this is really something that's dedicated towards a computer. We're just piggybacking on English, on this understanding of English, to make people understand what these test cases do. All right. So at this point, you might say, like, I've seen this before. This is behavior-driven development. Not really, right? Because behavior-driven development is solving a different problem. They tell you how to do your testing. Right? They say define a test set for a unit, then make the test fail, then implement the unit, and then verify that your tests pass. Nothing we've talked about here is telling you in what order you should be doing your testing and your coding. Only thing we're talking about is how can we write test cases that will convey to both the business and other people at the organization implementing the code, as well as the customers, if you want to, exactly what is being tested. And this is where we have the overlap. Both of these things focus on the ubiquitous language, right? And I'm not going to lie, it has some amazing tooling, and we're going to steal it, right? We're going to take the tooling from BDD, and we're going to get rid of a lot of the concepts of how you should be doing things from BDD. Right? The way I look at it is you can have different diets different ways you can eat, but you can take some of the tools from one diet to the other diet, right? If you want to be a localvore paleo person, you're going to need a frying pan, and you're going to figure it out real quickly. And if you make an amazing frying pan, then I can take that frying pan and I can use it to eat something else too. And that's what we're doing here. So we're going to be using Cucumber. In reality, we're more tied to Gherkin. So Cucumber is the implementation of Gherkin. Gherkin is the given when then syntax. The implementation of Gherkin for C# is called SpecFlow. It comes with parsers for lots of languages, both from a code perspective as well as from a natural language perspective. So you don't have to just use English. There's lots of other options out there. I've not used anything but English in this particular case. And the way it really works is it just uses a bunch of regular expressions to map to some code. Out of the box, it doesn't support variables, but you can implement that. So the thing that you need to implement to make that work is repositories, right? You're going to create a repository to keep track of all your employees. And then you just make sure that when you have something that gets a string passed to it, right? Some text passed to it, you can say like, well, maybe I should interpret this text as if it's an employee. Is there something in the repositories, and you can just ask all of the repositories and just say like, hey, does anybody have something that has this name? Right? So in this particular case, we create a new employee, E3, and it has the reports E1 and E2. We can just say like, well, we have reports. Reports is supposed to be a list of employees. Do I have a repository for employees? Yes, I do. Do you have something called E1? Do you have something called E2? Okay, give me those two things, and I'm going to build up my list from that. Now, one of the things you might say is like, yeah, that's kind of neat, but our objects have a lot more properties, right? It's not just 3 or 4 properties. It's more like 40 or 50 properties. That's true. And that's going to create lots of different options, right? If you have 24 options and they're just true or false, you have millions of options very, very quickly. But in reality, how many of those really merit testing, right? If you're dealing with customers and you have customers which can be delinquent, and you can have customers which can be new customers, and you have customers can be VIP customers, and you can have customers that are like internal customers, what's going to end up happening is some of these things just don't make sense. Right? You're probably not going to have a delinquent internal customer. You're probably not going to have a delinquent new customer. All of these different combinations really don't necessarily make sense. So even though you have a lot of possible combinations, only a few of these make sense. And what we can do is we can go back to this concept of golden data. And we can just say like, well, hey, we're going to specify a specific type of employee. And we're going to say that an employee of type contractor is going to have certain properties associated to it. So we're still using golden data, but we're using the golden data at a much lower level than, our top organizational units. And what that allows us to do is to make it more maintainable, right? Because you are having smaller units of golden data. It's much easier to say like, okay, well, we have a change. We have to choose some of these new properties for some of these chunks of golden data. So let's say you have 10 different types of employees. If you introduce a new property, chances are some of those types of employees are going to make use of that new property, and you may now have 11 types of different employees at the end of it. But what's going to happen when you introduce a new concept dealing with contracts or payroll or something else that isn't dealing with employees, then you're going to just create a new type of contract. You're going to create a new type of payroll schedule, right? But you don't have to create a new version of a customer, of a company, of an employee, of these larger objects that you may be dealing with every time you add a property to one of these domain objects in your application. And you may say like, well, this is nice, but this is going to create a lot of steps to describe exactly what's going on. Steps are these like little sentences, right? These are the little chunks that we build up our test cases from. That's true, but you can make some things generic, right? For instance, validation. Validation can be very generic, and you can just build out some more of the coding concepts. you can use dot notation, right? So in this particular case, we have a validation step at the end, then e2.reports contains the value, name, and there's a regular expression there. So what you can do is you can make solutions that still utilize this language, but also support enough flexibility that you can still convey enough information while making it work for generic examples. So in this particular case, the way that this would work behind the scenes is when you do this validation, it will say, like, okay, I got a string passed to me, e2.reports. I ask all the repositories, does anybody have this e2 thing? Somebody does? Awesome. Give me that. Okay, so now that I have an object, do you have a property called reports? Well, that's simple reflection. You can do that. Great, you find a property.reports. Now you know it should be an enumerable just from the way that the step is set up, and then you can say, like, okay, well, do I have any of these objects which have a property called name that then have a match to this regular expression? And I can just check that the thing that's passed in there is a regular expression just by parsing out the strings themselves and matching them against different patterns. So you can build a step like this that can handle a very large amount of your validation logic, even though it doesn't necessarily know about much of your domain object. All right. Another thing you can do is don't tie yourself to details that don't matter. This is another way you can reduce the number of steps. So this is a little simple Googling example, right? So we're going to navigate to Google. Then we're going to enter Possum Labs into the element search. Then we're going to click the element Google search. And then the page contains the element about. Now, you can read this and you understand that, oh, this is talking about Googling something, right? You still understand what it does. Chances are a lot of these things are not going to change, right? Search is a useful thing to be searching for. Right? Possum Labs is whatever you use as a golden data in this particular case to just make sure that, hey, we have something to search for and we know it should include an about link on the next page. But one of the things we don't do is we don't worry about how we click this Google search thing. And that's important. I go on the Google search page especially because there's a few buttons called Google search. It's just on top of each other. But you're not worried about, are there buttons? Are there links? Is this a submit? Is this, some kind of other structure? Because when you're building these tests in the natural language, you're not really worried about testing those things. You're worried about the workflows. You want to show to the business that the workflows work. The code that worries about, hey, is this button visible and does nothing overlap on this button? And this is supposed to be a button and not a link. Those are your unit tests. That's not really what the business cares about, and you really don't want to use the same tooling for both of these problems. All right, let's talk about some of the examples on how you can interact with your main application. So in this particular example, we're going to be assuming you're going to be writing your test cases long after you have written your application. So the first thing you want to do is ignore your existing model. Your existing model was the best guess people had at the time. And you know what? The business since that point changed. Chances are that if you work with the business today, and you build a domain model from the language they use, right? You can just talk to them and keep repeating back to them in this very primitive English. I heard you say this. Is this what you mean? Right? And you may find out that when the business says customer and user, it's the same thing. And maybe it was at one point. But then, maybe for other people, when you use customer and user, they are not the same thing. They're like, yeah, a customer used to be a user, but since that time we started getting customers and they wanted to have multiple users tied to a single account. And for us, a customer and a user are not the same thing anymore. Even though in the application, it may look very similar, right? They may even live in the same table because the only thing people have done is just tied some keys together behind the scenes to make it work. So try to ignore your existing model and work with the business to understand what they're doing, right? Ask somebody external to do it if you are worried that people have too much of a preconceived notion of how things work. And use that language to build out your test cases. And the biggest reason is that you're going to find out that some of your ideas are amazing. And you're going to come up with the same thing again. And in some areas you're going to find it's going to be different. And that's places where the business over time has changed and the model no longer matches what the business is looking for. Chances are you're going to have to build a layer to map between the new model you created and the model that exists, right? It's an anti-corruption layer. Now, this may initially look like a lot of work. And if you're going to add a whole bunch of code in there, it's like, well, that's a problem. Because how are we going to maintain this? Is it going to keep growing? Well, you're going to keep adding to it. But what you're going to find is you're going to be deleting more than you add. And the reason that you delete more than you add is that the code over time is going to have to conform to what the business is looking for. So even though you may start out, and especially in old applications, you may have a lot of things in there. You may have entities that don't even match anything that exists in the actual code, right? Some of these things that the code thinks are the same thing to the business are very different things. What's going to end up happening is over time that's not going to stay the same. The code is going to have to match what the business wants as more and more requirements roll out. So when you create this anti-corruption layer, what you're going to find out is that you're going to end up deleting more. It's actually going to be shrinking over time rather than growing. And if it is growing, that means that either your test model is wrong, or somebody is coding up a whole bunch of stuff that doesn't match what the business is looking for, and it's probably going to create problems in the long run. So it's a good indicator. So when you're dealing with testing a UI, try and tie yourself to the visual elements. Say when clicking search, when entering Bob for username. Because the visual elements are unlikely to change very often. People don't like their buttons to have different names because they're updates all of the training material, and people are looking for things. And when people read advice on Stack Overflow for your application or anything like that, will say click this button, I can't find this button, and people are frustrated. Once you put something onto the user interface, chances are that if people can read it, changing it becomes really expensive. So tie yourself to those things. If you're dealing with testing against an ESB or an API, right, so code interfaces, just map your domain objects to the message objects. Don't take the message objects wholesale. It's very tempting, but it's not something you want to do. On the other hand, if you're dealing with database testing, you may say like, ooh, this is amazing. I can just use my object relational model, right? I can talk about the database and I can get a little chart and it will tell me everything and how it relates to each other. Yeah, we'll talk about that in a second. I would advise that you just take your objects and you generate an ORM and then you just map your stuff to that. The database model is a giant trap. It just is. It looks like, this is amazing. The answer is in the back of the book. I can just look at it right now. But there's some problems, right? There is no correlation of the business importance to the number of references your table have, the number of rows your table have, the number of columns your table have, or your table name. None of those things really matter. Because what you're going to find is that the tables that are tied to everything are quite often non-functional requirements. For lots of organizations, the concept of a user is something like, yeah, we need a user and there needs to be some access to these things. But what we deal with is shipping, right? We care about shipping. Users are a non-functional requirement that we need. Even though everything in your database may say like, oh, this user did this at this time. In this session when they were logged in from over here, right? All of those information, it's very important and it's non-functional requirements and they need to be there, but they're not what your business cares about. So if you take your database and you grab all these objects and you go to your business with them, they're going to say like, well, I don't know what this means. I don't know what this means. What does this do? And after you tell them, they're like, oh yeah, no, that's important. But what you've lost is the ability to have them fill in what's important, right? And you're going to muddle the waters very quickly. All right, so let's look at what kind of code you'd need. Right, you need some code to define your domain objects. This happens to be C#. In this particular case, I have an interface that we implement, and that is tied to this log format. And the reason I want to say that whenever I have domain object, I want to be able to log this information after my test is completed to find the information. Right? This may include your database IDs, so that after a test fails, it's very easy to go back and say like, okay, well, here's the output, right? Here's what the test did. And you can now say like, well, E3 should have these values. It didn't have those values. And then at the end, you can say like, well, E3 has a database ID of 42. And now we can actually find it, and we can actually look at the actual data and see what's going on. You need some repository code, but most of that can be generic. Right? You need some sort of repository step base, which handles your mappings. This particular implementation is SpecFlow as well because it's C#. And then you need some steps that say like, okay, well, I need some employees, and I may need to apply some templates to them if they have a particular type. But that's about it. Most of the actual code that's dealing with it, that's doing the reflection, that's handling this conversion from tables to objects and things like that, that's all reflection. It's all generic. So you only have to write that once, and then you can just piggyback on that code for every single domain object you have. And then you have the specific steps, right? This is where most of your code's going to end up. This is where we are testing our retirement manager. This is where we have the stuff of the root employee is, the employee retires. And you may notice in here it's like, well, but you're taking in a string, right? Because the regular expression, they match strings, but you're accepting an object. Well, that generic base class we just looked at, why doesn't it have a mapping in there that just takes a string and turns it into employee? So that way, when people are entering text in there, it automatically gets mapped across, and you don't have to do it in every single one of these steps that you implement. So the actual code for this is available on GitHub. It's Bosshammer/DSL Tutorials. It's in the MIT license. What it includes is generic variable repositories and the resolution codes. This handles all of your reflection for you. It has some of these generic validation steps you saw. It has the test cases you saw in the presentation. It has generic access for web pages that focus on the human readable elements and a whole bunch of examples. Anyway, thank you for your time, and let me know if you have any feedback. Okay, where are you? There you are. Extension, no, record.